Today we're going to start chapter 4. This is chapter 4, section 1. We're going to start talking about plotting points. So we're going to have some overlap from some stuff we did back in chapter 1 where we had identified domain and range and kind of fill in tables. But now we're going to go one step and graph these things. So the first thing we got to do is it says if you extend the x-axis and y-axis to include negative values, you divide the coordinate plane into 4 regions called, and these are called quadrants. So you're going to cut it into 4. Quad is obviously the prefix for 4. So quadrants is really our lone vocabulary word here. So you're used to seeing this part of a graph, and you see this a lot in science class where you have like change in temperature over years or things like that. And then in math class, you see a lot of this stuff when you're talking about interest, when you're talking about money, when you're talking about savings accounts, all that stuff. But what they're saying is if I extend these to go on both directions forever and ever and ever, instead of having just one square to look at, I end up having 4 total squares to look at. Okay, quadrant 1, very important that we know this. Quadrant 1 is always going to be positive, positive. So it's positive in the x, positive in the y. We're going to the right and we're going to the and up. Quadrant 2 is always negative in the x-axis, but still positive in the y. Quadrant 3 is negative, negative. We go back and down. So what's left is negative and down is negative. And then quadrant 4 is positive in the x, but negative in the y. Okay? So again, as long as you understand right and up is positive, left and down is negative, this should be very, very easy for you. All right, the next example we have here is we have several points plotted. And if we take a look at point A, this is already kind of mapped out for you. Now, the thing that we got to make sure we know is you always revert back to the origin when you plot a point. Always. This is always your starting point. It's like a board game, right? This is where you always start, and then you get to travel however you choose. So if I want to talk about how I'm going to label point A, I got to go left to right first, up and down second. So I'm going to move on my x-axis first. So for me to get from this point over to A, well, I have to go back 1, 2, 3 points because now I'm right under A. So I went back or to the left 3, which is negative 3. And then to get to point A, I got to travel up 4 spaces. And I went up, so it's positive. So my ordered pair for A is negative 3, 4. Now, the next one I want to look at is if I wanted to get to point B. For me to get to point B, go back to my origins where I start. I go over 2. Now I'm directly underneath or above B. I went over 2 and I went in the positive direction because I went right. But now I need to go down 1, 2, 3 spaces to get to B. So this ordered pair would be positive 2 because I moved to the right on the x-axis, but I went down 3 units on the y-axis. Okay, so if I wanted to talk about labeling point C, well, when I go to my starting point, I am nowhere, or I am directly underneath C. I don't have to travel at all left and right. Okay, so my movement is going to be 0 for the x-axis, but I still need to travel up 2 places. So up is positive, so the ordered pair for C would be 0, 2. If I wanted to do D, all right, so if I want to talk about point D, I again go to my origin. I go right 1, 2, 3. So I traveled 3 units to the right, and I go up 1. So my ordered pair here would be 3, 1. Both positive because I traveled to the right and up. Lastly, for E, I want to go back 2 spaces to get directly above E, and I'm going to go down 3. So I went to the left 2 and down 3. So my order pair would be negative 2, 3. Okay? All right, on your own, well, we would do this one together. So now I want to do the opposite. I'm going to give you the ordered pair. You need to plot the point. Well, if I'm going to do this, I always, again, start at my origin. So I'm going to highlight it so I remind myself to start there. So my first point is negative 4, 4. Well, the x-axis is back 1, 2, 3, 4. And I need to go up 1, 2, 3, 4. And that's my point A right there. Okay. If I want to label point B, 3, negative 2. Well, I start at my origin. I go over 3 to the right, 1, 2, 3. And I'm going to go down 2. So 3, negative 2 is point B right there. Lastly, if I want to plot point C, start at my origin, and it's telling me to move 0 units left and right, but to go down immediately 4 units. So there's point C. All right. All right, our next example tells us to graph the function y equals 2x minus 1 with the domain at negative 2, negative 1, 0, 1, 2. Identify the domain and range. So this part is kind of the review. All right, but the first thing we need to do is we need to fill in this table. So remember, the domain is your x values. I'm kind of spoiling the last part of the question here, but the domain is your x values. So in my table, I already know that my x values are negative 2, negative 1, etc. Okay, so that's filled in for me because there is no choice of what that's going to be. Now, when I put these in, if I put negative 2 into this function, all right, 2 times negative 2 minus 1 is going to give me a negative 5. When I put negative 1 into this function, I get negative 3. When I put 0 in, I get negative 1. When I put 1 in here, I get a positive 1. And when I put 2 in there, I get a positive 3. So all I did was I just plugged each domain into this equation, and whatever the answer came out to be, that went in my y column. Okay, so now I can plot these points. So negative 2, negative 5 is the first point. So I go to the left 2, down all the way to the bottom here, negative 5. Next, I'm going to plot the point negative 1, negative 3. So I go back to negative 1, down 3. Third, I'm going to plot the point 0, negative 1. So I move left and right 0, and I go down 1. Now the point 1, 1, over 1, up 1. And then lastly here, plot the point 2, 3. So I go over 2 and up 3. Okay, so finding the table values was probably the hardest part. Plotting your points. Okay, and identify the domain and range. So obviously then if this is the domain, your y values are always your range. Okay. Now, on your own, I would have you do the next two. So on your own, you should try plotting these points, filling in this graph. And I forgot to give you a graph for that. So what I'm going to do is I'm going to plot these points on this graph, erase it, and then plot this equation up here as well. So take a minute and try. Let's do this one first. So take a minute and try just this example right here. And then I'll let you do this one on your own. I'm going to have to do it on this graph. All right. So hopefully you paused the video and you took a shot at it. Let's make sure we can plot all these correctly. So point A is at 2, 5. So we're going to go to the right 2, up 5. There's point A. Point B is -1, 0. So we go to the left -1 and we travel nowhere up or down. Now we're going to go do C is at -2, -1. And then lastly, D is at -5, 3. All right, so hopefully there were no issues there. Now, if we take a look at our next example, it's very similar to what we did 2 examples ago. It says graph the function -1/3 x plus 2 with the domain -6, -3, 0, 3, and 6. Well, again, I've already filled in the domain part of the table for you because there's no negotiation on it. That is what it is. Okay, but in this case, I'm going to plug in -6, -3, 0, 3, and 6 all into there, and I'm going to see what I get. All right, so when I plug -6 into this, this would give you 2, 4. All right, so -1/3 times 6 would give you a -2. Let's see, I didn't get that wrong. -1/3 times -6 would give you your 2 plus 2, yeah, would give you 4. Okay. If we plug in -3, so -1/3 times 3 plus 2, this would give you +1, this would give you 3. Plug 0 in here, I would get 2. When I plug 3 into this equation, it's going to give me -1 plus 2 will give me 1. And when I plug 6 into this equation, +6, this is going to give me -2 plus 2, which is 0. Okay? So again, all I do is I put the x value into the equation to get my y value. Now, if I want to graph this, all right, my first point, -6, 4. So I go to the left, -6. I don't have space there. And I would go down, up 4. So it'd be out here somewhere. -3, 3 would be my next one. So I'm going to go back 3 and up 3. My third point would be 0, 2. 0, 2 would land left and right 0, but up 2. And then my last point here is going to be 6, 6, 0. But again, I don't have 6 on my graph, so it would be out here on the x-axis. Okay? All right. Last example here, as always, is a word problem. So it says in 1920, the ratification of the 19th Amendment to the United States Constitution gave women the right to vote. The table shows the number to the nearest million of votes cast in presidential election, both before and since women were able to vote. So as we look at this table, okay, this is kind of like the line. This is when 1920 happened. And that's, you know that because the 0 is telling you how many years have passed since 1920. So if 0 years have passed since 1920, that's the year 1920. Okay, so this is all the stuff before women had the right to vote. This is all the stuff after the women had the right to vote. All right, so question A says explain how you know the table represents a function. Part B is to graph the function represented by the table. And then you want to describe any trends in the number of votes cast. All right. Well, the first thing is, how do you know this is a function? Well, if you think back to, again, chapter 1, a function is when every x value gives you one distinct y value. Okay, so for example, if the x value is 2, it doesn't give you the answer of 3 and 7, right? So if you remember, we talked about this, you would have like a table, of X and Y, and you'd have like 1, 3, and 4, and 1. And then the Y coordinates would be like 0, 2, 9, and 0. This would be a function because the 1 repeats, but every time you see it, you get the same Y value in return. When this happens, it's no longer a function because your X value of 1 is giving you 2 different Y outputs. So not every X value has a distinct Y value. So this would not be a function. So there's just a quick review on what it means to be a function. So how do I know this is a function? Well, every year there is a every year has its distinct Y value. Okay. All right. Graph the function on the table. So this is going to get kind of tricky because there is the scale is going to be a little bit off here. So if we count, let's see here, we got to do -12, -15. So there is 2, 3, 4, 5, 6. So if each one of these spaces is 2 units, so this is 2, 4, 6, 10, 12, and those are obviously all negative. And this is 2, 4, 6. All right, and then we got to get up to 40 here, so each one of these units. So if we do what? Each one of these is 5, 5, 10, 15, 20, 25, 30, 35, 40. All right, that works. Okay, so we just had to adjust our scale there so the numbers fit. Our first point is at -12, 15. All right, so we are going to go back all the way to the left of -12, which is going to be on the last line of the graph. And we're going to go up to 15, and we're going to put a dot there. The next one is -8, 15. And then we are at -4, 19. So -4, 19 is going to be just before 20. And then now we're going to go 0, 27. Right there-ish. 429, so just under 30 here. And then 837, which will be just between 35 and 40, and then 1240 is all the way up top here. All right, so hopefully there were no issues plotting these. I think the only challenge here was actually figuring out your scale for your graph. All right, but we talked about how we know it's a function. We graph the points. Now it says describe any trends you see in the number of votes cast. Well, I mean, you could really almost make the argument, and I don't mean to, not allow you to think for yourself here, but after the split here, after women were allowed to vote, the voting, the votes cast were almost double. Right? I mean, 27 and 29 are close to 30, and if you double 15, you get 30. If you double 19, you get 38. That's pretty close to double. You could say that when women couldn't vote, it never reached 20 million votes cast. I think the biggest one is that the votes, which they should double because roughly, half the population is men, half the population is female. So if only half the population can vote back here, when the other half can vote, it should be pretty close to double. Okay. So for tonight, guys, there will be no homework. This was just get the notes in front of you. We'll do some work and stuff on it tomorrow. If you have any questions or need anything, shoot me an email. Otherwise, have a wonderful rest of your day.